So for our first example in section 11.2, we're asked to find, or we're told the circle graph shows the types of grass planted in the yards of one neighborhood. We are asked to find the measure of arc KLF. So we see that arc KLF is this major arc right here that corresponds with the centipede grass. Centipede grass makes up 65% of this neighborhood. So we know that 360 degrees in that full circle, because that's the same as the central angle that goes all the way around, we want the central angle that corresponds with that 65%, the centipede grass, or the arc FLK. So we want 65% of the 360 degrees. So we can just take 0.65 as a decimal, multiply that by 360 degrees, go to our calculator, and we get 234 degrees. That is the measure of both the central angle and the corresponding arc, major arc, FLK. So we'll continue down. We see an arc addition postulate here that, like segment addition postulate, angle addition postulate, allows us to add two arc measures to each other to make a full arc. We see that there in the arc addition postulate. So now on example 2, we're asked to find the measure of arc BD. So we see that arc BD is right there, and some different divisions within the circle. A couple of angle measures are provided for us. There are a few different ways that you could approach this problem. Something that might jump out at you is that the 97.4 degree central angle there would be the same as this angle BFC, because they are vertical angles. That can be helpful for us. But I think the biggest thing to look for here is that we want to look for a diameter. We know that a diameter splits a circle in half. So we have two diameters here, AC and BE. The most direct diameter that's going to help us is that BE diameter, because on the bottom part we have a 52 degree angle, okay? And the part that we're missing right there, we know that is the central angle that corresponds with the arc that we're trying to find. So if this diameter means that this BE arc is 180 degrees, from that 180, let's subtract away the 52 degrees, and we're going to be left with the measure of our remaining central angle, which is our remaining arc, 128 degrees for the measure of arc BD. We can take a similar approach for example 3, where we're asked to find the measure of arc JKL. So again, down here, JKL, we are interested in this arc right there. And again, it's helpful to identify a diameter. You can probably see where we're going with this. The diameter JM splits that circle into equal parts. The left side, we have 180 degrees there. We have a 40 degree angle for arc JM. So the remaining part, JKL, is what we're trying to find. So 180 degrees minus the 40 degrees leaves us with 140 degrees for the measure of arc JKL.